All right. Okay, we'll take this and then we'll stop. The open interval -1 to 1 is the range of option A, x upon 1 plus mod x, option B, cos x minus sin x, option C, x raised to 4 plus 4x cubed plus 1, option D, mod of x upon 1 plus x, where x is not equal to -1. This is from NEST 2011. Okay, so the question is a bit different. Usually in the question the function is given, and in the options the ranges are to be the range is to be selected. Here range is given and we have to select the function. Okay, we have to select the function. Let us start with option C. Clearly option C is not right because it has the function x raised to 4. So if you take the limit of function in option C as x tends to infinity, that will be infinity. Is that clear? Which means we can say there exists x in the set of real numbers for which fc of x is greater than 1. Okay, so option C is gone. Now go to B. Okay, go to B. Now there is a typical trick that we bring in when we are asked to simplify this type of functions. Do you know what that trick is? Sorry?
Multiplying 1 by root 2.
Yeah, 1 by root 2, exactly. So the trick is you have to square the coefficients of cos x and sin x, add them and then take the root, because you can express it as an acute angle. Okay, you can express it as an acute angle, but that's fine. So here that turns out to be 1 by root 2. So you take root 2 outside and then you take 1 by root 2 inside. Okay, either write it as sin pi by 4 cos x minus cos pi by 4. Either way it is fine. It is according to the question you have to select it appropriately. Sometimes in differentiation when you are simplifying it, if the outer function is cos inverse, then you have to make sure that the term inside is compound angle of cos. That's fine. Now this is sin a cos b minus cos a sin b. Correct? Sin of a minus b. Now doesn't matter what angle you have inside. What angle you have inside. This range, the range is minus root 2 to plus root 2. Raise your hands if you understood this. Sine lies between minus 1 to plus 1. So root 2 times sine will lie between minus root 2 and plus root 2. So C is also gone. Sorry, B is gone. B is gone. So it's not B, not C. So either A or D. Okay, it is either A or D. How do you think you can decide between A and D? Because they more or less look the same. In option A we have got x upon 1 plus mod x, and in option D we have got mod x upon 1 plus x. Yes, okay, of course x is not equal to minus 1. Please. What can we do to solve this particular problem? Look, when they say that x is not equal to minus 1, something immediately should come to your minds. And what is that? That is, if you look at the graph of FD, if you imagine how the graph would look, this graph will show similar behavior as that of 1 upon x at 0. Do you remember how the graph of 1 upon x behaves near origin? Yes. If you approach it from right, you will get extremely large numbers. If you approach it from left, you will get extremely large numbers in magnitude but negative in sign. Something similar is expected from D also. Okay, why is that? Look, it's a very simple question. If you decide to find out its limit, okay, let's say it's right hand limit, suppose x tends to negative 1 from right, okay, mod x upon 1 plus x. Please observe this carefully and tell me whether you understand it. When x takes values which are close to -1 but from right, mod x is going to approach 1, no matter, okay, either from left or right, doesn't matter, it is going to approach 1. But what is going to happen to the values of 1 plus x? Do you agree that the values of 1 plus x will tend to 0? Yes or no? If x is going to -1, 1 plus x will go to what? 0. Do you agree to that?
Yes.
Does everybody agree to that?
Yes, sir.
Exactly. So this number is going to get smaller and smaller and smaller, which means this will resemble the behavior of 1 upon x like this. And this in itself is enough to convince you that there will be some real number x near -1 for which f of x will not be in the range, in the interval -1 to 1. Let us take an example. Okay, what example can we take? Let us take x as negative 0.9. Suppose we take x as negative 0.9. So what will be fd of negative 0.9? In the numerator it will be 0.9. In the denominator it will be 1 minus 0.9, and this turns out to be 9, which is greater than 1. So we have now found out a point in the domain of the function in option D whose function's value exceeds 1. So what option is right? D is not right. D can't be right, option A is right. Okay, is that clear?
Yes, sir.
Yes. I have one more homework for you, and that homework is find the range of x upon 1 plus mod x. Try doing that. Let's see if you can solve it. Okay, well, you know the answer. The answer is it's in between -1 and 1. But how to arrive at that conclusion? Now we arrived at by eliminating other options. Okay, because that was easier. But if the question is just to find the range of x upon 1 plus mod x, like if I take option A as my question, and if I give you 4 intervals out of which one is -1 to 1, then how will you solve it?